Well, let me go ahead and unmute myself. So for 3.2, I did apologize at the beginning of the video for being on a struggle bus and it taking me a minute to start this recording. This is where we get to actually apply what we learned in 3.1. We'll be writing a lot of capital T's and a lot of capital F's. I'm going to open up the homework and do one problem with you after this video is done, just so that you can see how my math lab will want you to enter things in. Okay, so this is truth tables for negation, conjunction, and disjunction. It's section 3.2, okay? So what you will learn upon completion of this section, you should be able to understand the truth tables for all of the different connectives that we learned. You'll be able to construct a truth table using all of the different connectives. You will understand the alternate method for constructing truth tables, which is going to be like the easier method. And then you should be able to determine the truth values of statements without actually constructing the truth table. Okay. Now, I do know that this actual PowerPoint does go through a bunch of different slides just explaining the steps. So at first it's going to be kind of boring and it's not really going to make any sense until we actually do like an applied problem. So I would just write the steps down and just kind of pause the video if you need to, okay? So a truth table is used to determine whenever you have compound statements. We want to know whether this compound statement is true or false. In 3.1, we learned about simple statements. They convey one thought or one idea, and it can be judged true or false. For a compound statement, you put together multiple simple statements. And in order to figure out if our compound statement is true or false, we need to be able to take into consideration all of the possible outcomes that we could encounter. Okay. So what we use is a truth table. So this right here is a very simple but very important negation truth table. If you notice, they have case 1 and case 2. On the top row, second column, you have our, let me see, there's my mouse right here. This is our letter P. This is our statement P. Now, if you go down from that P, case 1 is where our simple statement is true. Case 2 is where our simple statement is false. Okay. Now, if you scoot over to the right, you notice that they negate P. They take not P. So if in case 1, our simple statement was true, and then we negate it, it becomes false. In case 2, where our simple statement is false, when we negate it, it becomes true. Okay, remember that the negation of a statement is always the opposite truth value. Okay, now here is a compound statement truth table. For a simple statement, you only have one statement. So you would only have just P, right? Now for a compound statement, we would have multiple statements. Here, the statements that were given are statement P and statement Q. Because we have 2 statements here, we have a total of 4 different cases. Okay, so here's case 1, case 2, case 3, and case 4. For case 1, we have the combination of the first statement being true and the second statement being true. So true and true for both statements. For case 2, we have P being true and Q being false. For the third case, a possibility would be that our first statement is false and our second statement is true. And then lastly, for our fourth case, we have that our first statement is false and our last statement is false. This setup, TTFF for the first statement and TFTF for the second statement, is like a generic standard table that we will always be given and that we will always start with whenever we have our truth tables. Okay. It is something that I've usually asked as like a bonus problem on a test. Okay, now here is the truth table for a conjunction connective. So if you notice case 1, 2, 3, and 4, the P statement and the Q statement, this is all the exact same from the previous slide. Now over here on the first row, fourth column, you notice you have P and Q. So what they're going to do is they're going to teach us now what happens whenever you take the conjunction of these two statements given these different cases. If in case one, your first statement is true and, right? The connective conjunction means and. So if P is true and Q is true, your outcome is true. What I teach my students is P and Q at the same time true? Yes. Therefore, the outcome is true. Now look at case two. P is true, Q is false. Now do like I said. Is P and Q at the same time true? No, it's not. So we put a false. And if you notice for case three, you get the same outcome because both P and Q are not true at the same time. Similarly, in case four, both P and Q are not true at the same time. Therefore, the outcome is false. So very, very important here. The conjunction is true only when P and Q are both true. Okay. The conjunction is when we say the words and. So that's why I say, is P and Q true at the same time? If the answer is yes, then the outcome is true. Okay. So T and T equals T. Okay. Everything else with that and or that conjunction symbol, you get false. Now let's talk about the disjunction truth table. So just notice everything, case 1, 2, 3, 4, the P statement and the Q statement, y'all, nothing has changed here. What we're doing is we're looking in this first row, fourth column, where it gives me the disjunction connective P or Q. Now, what I teach my students here is P or Q true? If either of them are true, your outcome is true. So look at case 1. Is P true or is Q true? Yes. So you write true. Case 2. Is P true or is Q true? Yes, at least one of them is true. Therefore, the outcome is true. For case 3, is P true or is Q true? Yes. Therefore, you write true. Lastly, is the statement P true or is Q true? Both of those are negative. So your answer would be no. Neither of them are true. Therefore, the outcome, right, the truth value of this disjunction gives you a false outcome. Okay, so very important. The disjunction, or when we say the word or, is true when either P is true or Q is true or both are true. The only time, y'all, what I always write right here for my or is F or F equal F. That's the only time you get false whenever you have the or statement. Okay. Okay. Now let's talk about a negation. The negation, right? When we read the tilde and we had the P, it's read not P. So if your P statement is true, then not P is false. And if P is false, then not P is true. We talked a lot about that, in the 3.1 video. The negation gives you the opposite truth value. Okay. So in other words, not P will always have the opposite truth value of P. Remember, in math, they give you very generic things to use as kind of like a formula. Anytime you see this tilde in front of any letter that represents a statement, what it's saying is that you want to take the opposite truth value. Here, they're just going to use P, but it can be in front of a Q, it can be in front of an R, it can be in front of anything, okay? With our conjunction, that is our and, right? The conjunction, P and Q. P and Q is true only when both P and Q are true. Remember, is this and this true at the exact same time? Yes, therefore, outcome, true. Okay, disjunction. The disjunction is read P or Q. This, I need one or the other or both to be true. So P or Q, the outcome, right, of that operation, of that connective, is true when either P is true or Q is true, or they're both true. And I ask myself, is this or this true? As long as one of them is true, I write true. That's my outcome. Okay. So in other words, if your P statement and your Q statement are both false, that would be that case 4. With the or disjunction connective, that is the only time our outcome will be false. Okay, now constructing truth tables. I believe these are the slides where it's very wordy and it might not make any sense until we actually apply it to a problem. I would write everything down, or at least just listen really well, okay? This is how we do it. To determine if a statement, I'm so sorry, I don't know why I said to determine. Step 1, determine if the statement is a negation, a conjunction, a disjunction, a conditional, or a biconditional. Obviously, the first thing you need to do is see what type of operation you're going to be doing. So far, I've only explained the truth tables for a negation, a conjunction, and a disjunction. I've not talked yet about a conditional or a biconditional, okay? The answer to the truth table appears under, okay? It appears under the tilde if it is a negation. So what I'm going to do is I'm going to notice where I have a tilde written, and that's where I put the answer to that column, okay? And then it's going to appear under the conjunction symbol if it is a conjunction. So I'm going to do the work for that operation, and I'm going to write my trues or my falses under this symbol. If it's a disjunction and I do the operations, I write my trues or my falses under the disjunction symbol. Hopefully it kind of makes sense, okay? We're going to line everything out and we're going to put the answers or the values underneath the corresponding symbols. Then if it's a conditional, the answer to those truth values, the T's and the F's, are going to go underneath that conditional symbol. Y'all, I feel like I need to sneeze, and I feel like I'm going to, I don't think I should sneeze. It's going to hurt my stomach. Whew. Okay, the answer to the truth table for a conditional, I will put the values, the trues and the falses that are the answers to the biconditional under the biconditional symbol. Okay, step 2. We'll complete the columns under the simple statements, okay? I know about 2 different ways to solve truth tables, and I'm telling you, I do think that this is the easier of the 2. So we'll have our P, our Q, and our R statements, right? We'll have all the different cases. Then we'll have their negations within parentheses if we have negations. Okay, if there are nested parentheses, you always work within those parentheses first, because even though it might not seem like it, we are in a math class. Okay, for step 3, what we do is we complete the column under the connective within the parentheses. So if we have a conjunction, we would actually look at our statements, we would do the operation, and we're going to list our trues and our falses underneath that actual connective. Okay, we'll use the truth values, and we'll actually be able to do, or I'm sorry, I don't know why I said do. We'll actually be able to use them to determine the final answer, okay? So complete the column under any remaining statements and their negation. It's just kind of going over how there's multiple steps to do this, okay? So complete the column under any remaining connectives. The answer will appear under the column determined in step 1. And again, right now it's just a whole bunch of words and it doesn't really make any sense, but it will, I promise, okay? So for the conjunction, disjunction, conditional, or biconditional, we'll obtain the value using the last column completed on the left side and on the right side of the connective. Again, right now you're like, I have no clue what language she's even speaking. I promise it should get a little bit easier, okay? Now, lastly, for a negation, we'll negate the values of the last column completed within the grouping symbols. Okay, now we will circle or highlight the answer column and number the columns in the order they were completed. I recommend, you don't have to obviously, but I recommend having a handful of pencils or maybe erasable highlighters, colored pencils, something that will help you differentiate between the different columns that we're working on, and something that will allow you to circle or highlight that this is your answer column, okay? Okay, so what we're gonna do right now is we are actually going to construct a truth table for this statement, not, okay, I'm gonna read it the way that we know how to read it, okay? It is not true that not P or, I'm so sorry, blah, 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 blah. Take all of that away, rewind the video. Actually, don't, because you'll hear it again. I'm so sorry. It is not true that not Q or P, right? Now, I'm not going to be given sentences. I'm not going to be given anything. What I'm going to have to do is actually look at all of the different cases and then determine what the actual value is. So this is how you construct a truth table. Okay, so remember that truth table that I told you kind of just always stays the same, right? It's our standard. It's what we use. It's what we're always given as well. We have it right here. So on your piece of paper, I would write P, I would write Q next to it. Then going down underneath your P statement, we need to have all of our different cases. I always write true, true, false, false. Underneath the Q statement, you write true, false, true, false. And if you notice, they do kind of create columns. Okay. Now I'm going to take what it wants me to make the truth value for, and I'm going to write it next to my P and my Q, and I'm going to space it out just a little bit. Okay. You want to go and give yourself enough room so that you can answer these truth values. And like I said, not get too confused with where something goes. Okay. Now it would be too hard for me to go back, 4, 5, 6 slides and read through the way that they said to do these steps. It's going to make more sense just to go ahead and work through this with you. Sorry, I'm trying to adjust myself. Oh, and my side hurts. Okay, grab my ice pack. Okay, so this is what we do. We are going to start with the negation of P. Okay, what we're going to do is underneath not P, we're going to label it our number 1 because it is the first step that we're doing. Now, the way that we're going to take the negation of P is to look at our P column and you take the exact opposite truth value of what it shows you. So if you notice cases 1, 2, 3, and 4, the truth values are true, true, false, false. So if you look at the very first one, case number 1, the truth value for the P statement is true, right? So what would the negation of true be? It would be false. And then go down one step, okay? I'm trying to get my mouse here. This is what I just negated. This very first T, I negated and it became an F. Oh man, it tapped it for me. Let me go back. So sorry, I'm gonna move my mouse. Now, if you go down underneath our P statement, case 2, we also have a true value. So if you negate that, you get oh my goodness. Y'all, did y'all see what I did wrong? Look right here. What am I negating? I'm negating Q. So obviously pay better attention than I just did, because I just messed up and I don't want you to do that. We are not negating the P statement. We are negating the Q statement. So let's reverse just a little bit and look right here. My Q statements, all of the different cases are true, false, true, false. In this column that I've labeled number 1, I'm going to negate all of those truth values. If you negate true, it becomes what? False. Now look right here. The next truth value that I have for my Q statement is false. If you negate false, what do you get? You get true. Sorry for that mistake. Now go down again. If you negate that truth value, you'll get false. And then one more time to case 4 for our P statement, what we have is a value of a value of false. If you negate that, what do you get, y'all? True. Okay, now what we're going to do is we're going to scooch over and we're actually going to number the P column 2. This will be the second thing that we work on. And if you notice, nothing's been negated. It is just our P statement. If you look to the far left, all of those truth values under P, those aren't going to change. Those are all just going to be listed here because it doesn't have a tilde. It doesn't have a negation symbol in front of our statement. So we would just list true, true, false, false. Okay. Now, the third thing that we would do is work on our connective, and that is a disjunction connective, which is our or statement. So what I do is I'm going to look at column 1, which is right here, and I'm going to look at column 2, which is right here, and I'm going to ask myself, is this or is this true? If the answer is yes, then the outcome is true. If both of them are false, that was the only time that we would result in a false outcome with this connective. So I look right here. Do you see this false? And then do you see this true? Now ask yourself, is this or this true? Yes. Therefore, your outcome is true. Do you notice how I numbered this? Our third. This is the third place that I'm working in. Okay. Now let's look at this next row. Is this outcome or this outcome true? Yes. Therefore, the truth value is true. Now go down again. I need to ask myself, is this true or is this true? Because both statements are false, my answer would be no, which would mean that my outcome would be false. And then lastly, for this fourth case, I would ask myself, is this true or is this true? Because one of them is true, the outcome is true. Okay, so what I've done is I worked on the negation, I wrote my P statement, I did the disjunction, I finished the parentheses. Now what I do is I look on the outside of the parentheses. The only thing I have there is the tilde, right? That negation. Now I know I have a whole bunch of T's and F's and it doesn't really make any sense just looking at it to figure out what am I supposed to negate, but you go in order of the columns that you've worked in. So I'm going to negate the last column that I worked on, which was the third one. And I'm going to negate all of those truth values. And then that actually ends up being my answer column. Okay, so I'm going to number underneath this tilde for the negation, that column 4. Okay, and I'm going to actually negate column 3. So if you go row by row, the first truth value that I have is true. And if you negate a true statement, what you get is false. And then the second row for that third column, the truth value that I have is true. And if you negate a true statement, the outcome is false. And then that third row for that third column right here, the truth value that I have is false. If you negate a false statement, what do you get? Yep, you get true. And then lastly, if you look right here, fourth row, fourth column, the truth value I have is a T, which is a truth statement. And so if you negate that, what you get is false. Now, the reason why I said to have a highlighter is so that as far as on a test or on your homework, you can highlight this column because it is your answer column. Okay. We just constructed a truth table for that whole entire statement right there. So let me see why it says this. False only when P is false and Q is true. Okay, that's kind of moot because the actual work that you want is just the actual answer column that you get, okay? How crazy, look, it goes from example 3 to example 7. Okay, so let's see, it says use the alternate, blah, blah, blah. Use the alternative method to construct a truth table. So it wants us to construct a truth table for not P and not Q. So you always start with the 4 cases. You have your P and you have your Q, and it goes TTFF under your P statement, and it goes TF under your Q statement, okay? Now, the actual symbolic form that they gave us is going to go on the first row, third column, spaced out so we can do our work, like so. Because I noticed that within that symbolic form, both of my statements were being negated, because they kind of just jumped straight to this, didn't they? Do you see here? We have a not P as well as a not Q. I need to actually negate both of those. Those will always be the first things that you do as far as hierarchy is concerned. Okay, so we have a column for the negation of P. And if you look, our P column goes TTFF. So the negation of that column is FFTT. And then the negation of our Q column, because it goes TFTF, it will be FTFT. I told you, we're going to do a whole bunch of T's and a whole bunch of F's for about the next month, okay? Now let's see what they do next. This original symbolic form that they gave us was a conjunction, right? So it was our and. So what I need to do is I pretty much write the symbolic form again in its entirety at the end, because I need to negate them first. And then right here, I'm going to do the work. Okay. Now I'm going to use the negation of P and the negation of Q columns to find the conjunction of those negations. Okay, now I didn't know for sure if it did it one step or if it did it all together. So I'm going to talk through it, okay? Excuse me. Now, if I'm going to say and, if I'm going to do the operation of a conjunction, whenever I see this symbol, I ask myself, is this and this true? Are both of these true at the same time? No. So the outcome right here is going to be a false. And then right here, if I go down a row, is this and this true at the same time? No. So I'm going to get another F. And then if I go down again, it says, is this and this true? The answer is no again. And I know I haven't like kind of shown you the answer, but I don't want it to just throw it all up there at once. So far, what we have is F, F, F. If you look at this very last case, because it's a conjunction, I'm asking myself, is this and this true at the same time? Yes. Therefore, the final answer column would be F, 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 T. Okay. So with or, you need either one or both to get a T. With and, they both have to be T's at the exact same time for your outcome to be a true statement. Okay. Now let's see what they do. Oh, and then they highlight it, just for continuity. Okay. It's true only when they are both true. Okay. Oh, now let's do this right here. I think there's only like 2 problems like this on the homework. Hopefully these aren't confusing, but if they are, obviously, y'all just let me know, okay? So it says, determine the truth value of a compound statement. For each simple statement, then using these truth values, determine the truth value of the compound statement. So we're going to be given statements. We're going to create statements based off of those statements. And then we can just kind of simply figure out the answer without having to do a whole entire truth table. That's how it should be done, I believe. So it says 1 million is greater than or equal to 1 billion. Now just tell yourself, like, is that true or not? That's not true. 1 million is not greater than or equal to 1 billion. So I already know for a fact that that's false, but let's see what they have me do with it. Okay. They're actually going to have me let the statement P be 1 million is greater than 1 billion, because they're going to break apart that statement. It said 1 million is greater than or equal to, right? Those are saying 2 different things, greater than or equal to. So I'm going to let P be it being greater than, then I'm going to let Q be it being equal to, and then I'm going to actually combine it together as a compound statement. And I'm going to use the disjunction connective. Okay. Now, if you look at P and you look at Q, we can very easily tell that both of those are false, right? Look at P. 1 million is greater than 1 billion. That's false. Look at Q. 1 million is equal to 1 billion. We also know that is false. So if we actually bring down that symbolic form of P or Q and we substitute the P for the truth value F, keep that connective, and substitute the Q for the truth value F, right? Because we know both of those statements are false. Now we actually have a simplistic form of looking at the operation of this disjunction. And we know for a fact that the only time we get false as an outcome with the disjunction is when they are both false. Because look right here, wouldn't I be asking myself, is this or this true? No, neither of them are true. Therefore, the outcome is false. These are supposed to be an easier way of looking at truth tables, but they can be confusing. Okay. So, like, don't beat yourself up if they don't make any sense right now. Okay. But ultimately, what we could say was that the statement was false. Okay. Now, you remember how they use very, very realistic examples. Here comes one right here. So it says, determine the truth value of each simple statement. Then, using the truth values, determine the truth value of the compound statement. So here we go. Angelina Jolie is an actress, or Zac Efron is a janitor, but Johnny Depp is not a plumber. So we would have one that would become our P statement. We would have something else that would become our Q statement. And then I believe they would probably use R. So let's see. We're going to let P equal the statement, Angelina Jolie is an actress. We're going to let Q equal the statement, Zac Efron is a janitor. We're going to let R be the statement, Johnny Depp is a plumber. Okay, now using what we know about all of these individuals, we can take the statement that they gave us in words and we could write it symbolically, which would have our P or Q in parentheses. Then we would have the conjunction symbol, and then we would take the negation of R. Let me go back just a couple of slides. Do you see where it says right here, Johnny Depp is not a plumber? Because it has that negation, our R is him being a plumber. But in our statement symbolically, we negate it. Okay. Now, we know that our P is a true statement, right? Angelina Jolie is an actress. So P is true. We know that Zac Efron is not a janitor. So that Q statement is false. And we know that Johnny Depp is not a plumber. Therefore, our R statement is also false. Okay. So look at this right here. Because we know that our R statement is false, in our symbolic form, we're going to need to what? We're going to have to negate it. The negation of a false statement is what? True. Now we're going to take all of these symbols. It basically just said the same thing again, y'all. Okay, there we go. We're going to take all of these symbols and now we're going to put their truth values right underneath them. And then we're going to look at the connectives to actually figure out what the actual truth value is of this whole entire compound statement. Okay, now I know P, Angelina Jolie, is an actress, is true. So underneath P, I'm going to write a capital T. It's telling me that Q is false. So underneath Q, I write a capital F. Excuse me. In between them, I write that disjunctive. I don't know why I keep saying disjunctive. That sounds weird. Disjunction symbol. Okay. I have those in parentheses, and then I do my conjunction, and then I'm going to write the statement. I'm so sorry. I'm going to write the truth value T. I wanted to go and show everything here. I'm going to go and do the truth value T because I know that the negation of R is true. Now, if you notice, I still have the exact same thing written, but instead of doing, I'm not even kidding y'all, an actual truth table for 3 statements is quite extensive. So this right here breaks it down more simplistically for you. What I have in parentheses, the first thing that I'll operate on is going to be T or F, and then I'll combine it with and T. So think about our disjunction connective. This or that. I need this or that to be true. And then the outcome that I get is what? It's true. So underneath this parenthesis, I'm going to write true. And then I bring down the and true. And then think about our connective for our conjunction. When we say the word and, I need this and this to both be true at the same time in order for my outcome to be what? True. So I know that takes a while to get there, but the actual truth value of that whole entire compound statement is true. Okay, so the original compound statement is true. Okay, y'all. So that was it for 3.2. If you give me a second, I'm actually going to open up assignments. I'm going to do one of these truth value tables for you, preview. I don't think there's many problems on here, probably 13. Oh, I guess I timed out. So give me just a minute longer to get logged in. Oh, there we go. Okay, so that's a pull down question. There's another one. That one's fairly simple. I want to do one a little bit more complicated. Let's do this one. So if you notice right here, they give you your P statement and your Q statement, and they give you all of your cases. What they want us to do in this first row, third column, is negate the truth values for what? For Q. So if you look at Q, it goes TF, TF. If we negate that, it goes F, T, F, T, right? Now look right here. It's telling us to look at our P column, which is right here, and to look at our not Q column. And with both of those columns, do the connective or. So I need to ask myself, is this or this true? Yes, one of them is true. Therefore, the outcome or the truth value is true. Now ask yourself right here, is this or this true? Yes. What about this one? Is this true or is this true? No, neither of them are true. Therefore, what you get for a truth value or an outcome is false. And then lastly, is this or this true? Yes, one of them is true. Your outcome is true. And then you check it and it says, yay, good job. Okay. So that is how you do the homework. And that is how you do a truth table. This one, you would negate off of your R, which is here, negate your S column, which is here. And then you would take the or connective of both of them. Okay. So I'm happy to help. Thanks.